Breakfast. Sort of. Alrighty, tidy, folks. Welcome, or welcome back, perhaps, to, well, welcome to today's stream, and welcome back, perhaps, to the channel. Started up a little bit late today, later than I like to. I usually like to start around 1000 hours or so. Doing some research and some checker-rater ratings. I've been doing things, stuff, and things and stuff. Things and stuff. So, what I want to do kind of right now is face that guy down just a smooch, because I want to be able to use that to show you guys some stuff. The first thing I'm going to talk about, I don't care what you're going to talk about. You're not here to talk, I'm here to talk. You don't know me. First thing I'm going to talk about is the necessity to clean up this damn case. This thing is gross. I don't know why this thing's so nasty. Well, I do know why this thing's so nasty. It sits on the floor in the car. Which is not that far from its original home. The original home is on the passenger side, the bottom of the A pillar, underneath what used to be the glove box. It sits kind of, so as you're driving the car, it sits kind of up against the firewall like that, or the A pillar like that. Excuse me. So right now, actually, I'm just going to take the panel off. So that I can take them inside in a little bit, or maybe I'll do it out here. Maybe I'll do it on stream for you guys. Maybe I'll clean a thing. You can watch me like sort of being an adult, he says, not doing the dishes that he should have done yesterday. It's fine. It's fine. Everything's fine. Where did I put the screws? Put the screws there. I don't think there's any requirement to pull the PCB out of the case right now, as of this moment, this second. But when I get this panel off and I set it to the side wherever the heck I stuck the other one, I would like to talk about what I've done to the ECU and why the background music isn't actually frickin' playing. We're going to get that going for you guys. Sorry about that. There we go. Background music. Less boring. Probably. Maybe not. Probably not. Whee! Okay. I mean, the inside's great. The inside's fine. Take a look at that. The outside, however, is kind of gross. I'll give it to you guys here. A little bit better view, huh? The inside's fine. Got the other guy up there. That's fine, job's a good one. Alright, so let's talk about this ECU for a minute. Let's talk about where I stuck the other spare. I think in here. We're gonna grab him so I can more easily show you guys stuff and things. And I did, if you saw the stream from 2 days ago, you will have seen what I thought was a pretty good setup. I had the whiteboard lean forward with the Logitech here facing down at the bench, and then I had the Canon facing across the bench. The bench was this way instead of the way that it is right now, like this. And I thought it looked pretty cool, you know. Looked like, kind of reminded me of Luis Rossmann's setup, except he's been doing it longer, his is more fancy, he's been able to put more money into the setup, etc, etc, etc. Also, he's more tech savvy than I am. He's a Apple repair guy that just happens to post stuff on YouTube. who I also happen to agree very much with a lot of the things he says. So, I've got 1, 2, 3 ECUs. This one is the one that I run regularly, most of the time, all the time, some of the time, orange of the time. This guy is, this is the guy that I was using when I was doing chip burning. Chip burning is where you have a chip, which is the external memory, which is this guy here, I believe. I can't remember, it's this guy or this guy, one of these two. You have external memory that you have to tell the ECU that you're using, or you have to tell the MCU that you're using via J1 here. That says use this pin or this pin for your data, or this pin group, I guess, for your data. So when I was running this guy, I was running on Chrome 3, which has a few features not enabled, but is good enough. It runs an engine. I was running Chrome and just a single map size chip, which is, I don't even know the size of the map. Not big. 16 meg maybe? 8 meg? I don't know. It's not big at all. This was really annoying because what you have to do is you have to kind of drive the car around, kind of record or remember the bits that are wrong, shut the car off, pull the chip out, put it in the burner, start the laptop up, get the program going, make whatever changes you're going to make, burn the chip, pull the chip out, put the chip back in the ECU, and then start the car, start driving again. You can't do it on the fly, you can't do it live. Super annoying. And it took, I had the car running, I had a map on there that was acceptable, and I didn't blow an engine up. I was actually doing it on this engine, so obviously I didn't blow the engine up. The engine still runs just fine. I was doing chip burning one time when I drove to West Virginia from Nevada. I was living in Vegas, and I drove to West Virginia to see a grave of somebody dear to me. And I was either coming into Denver or going out of Denver. I can't remember which way it was. I was going down a mountainside, and apparently I did not have fuel cut turned on, and I had the low throttle fueling all kinds of screwed up apparently, because I was coming down the hill, and if I let off completely I would slow down. If I put the throttle down to 5 or 6%, so just even a small amount, but put the throttle down to 5 or 6%, I start accelerating. I didn't want to do either one of those. I wanted to kind of maintain going down a hill. So I was kind of right at that transition where most cars would be fuel cut, not fuel cut, fuel cut, not fuel cut, fuel cut, not fuel cut, kind of back and forth, even holding your foot steady as engine parameters changed a little bit, you know, and the sensors gave you a little bit of this, a little bit of that. I was not doing that, going down that hill. I was black smoke pouring out the tailpipe going down that hill. Because it was overfueled, and it was just dumping fuel into the thing. And it was funny because, like, going down that hill, I swear I could see the fuel gauge moving, like driving a Cadillac or a truck, where you watch the fuel gauge for about a mile, and you just watch it. You're like, whoa. It's a Honda, man. It's not supposed to do that. Come on. So that's this guy. This guy that's connected to the engine simulator, which I can show you guys. Let me set this down. The engine simulator is real cool. I looked it up the other day, and the name on the sales page says Motes, which would be Chris Motes. He and a few other guys back in the day. He still does it, I think, because well, I didn't actually look at motes.net, which is the server, the domain. Didn't actually connect to it. Maybe I should do that here in a second. So, we've got this guy. I've got a wire harness that I built, as it were. This is an engine simulator for these ECUs, which you could use it really for any 4-cylinder ECU, honestly. You just have to connect it to your computer. It's got pots for intake tip, coolant tip, throttle position, manifold pressure, engine RPM, O2 sensor input, the narrowband O2 sensor input, and the ELD sensor input, which is interesting to me because most people disable that circuit when they start doing any kind of modifications to their car, because it does some interesting things once you start modifying the car. An all-stock car, you wouldn't care what it does, but once you start doing a couple of specific types of mods, it starts to become not necessarily an issue, but a noticeable effect. So most people tend to get rid of it. I actually want to expand that. So at some point, what I'm going to do is, actually I'll talk about that here in a minute. Let me write that down. New ECU requirements. Actually, I need to start recording this too. I don't necessarily need this bit, but the bit that's coming up that I'm going to be talking about here in a second, I will want as a recording to make a video out of. I also, real quick, want to move you. I want to move you guys over here just the smoochily of smooches. Kind of like that. That way when I'm standing here, my head's not covered by the Logitech, which I do want to kind of keep up in case I need to show you guys something here while I'm pointing at something here. Kind of an edge case, but I'm kind of an edge case. Not kind of, I am definitely an edge case. Not a head case. I'm not a head case though. I'm an hedge case. Yes. Snip, snip. Maybe snip, snip. I don't know. Anyway, continuing on. So this ECU is chipped. A couple of days ago, I did accidentally broke the resistor. It's a 0 ohm resistor, so it's a jumper, but it came with the chip kit when I bought the chip kit to install the chip on this ECU. This guy was the first guy that I started running the Demon 2, which is this chip here. It's I call it a piggyback. It's an emulator. So this whole PCB simulates the memory chip, which I don't remember which one of these, but it simulates the memory chip. What that means is that you can make adjustments via USB on the fly, and whenever the specific memory, the address that you've adjusted is not in use, whenever the computer scans by it. So if the computer is scanning that address at that moment, it won't try to make a change because you'll crash the program running the engine and it'll probably just kill the engine. But what the emulator will do is I'm pretty sure there's a buffer IC on there that every change you make, after it scans past, it'll update that address, and then you can live adjust parameters for controlling the engine in the ECU and see them it happens on the next cycle, but the crystal in this guy is 10K? I have to look up that part number. I don't actually know how fast. It runs faster than a parameter in the engine will change. It has to, obviously. So I was running this guy when I first got the Demon, and what I noticed, what I discovered at some point, I was trying to tune the fuel cut, and for whatever reason, it wouldn't work. I couldn't get the fuel cut to work correctly the way I was trying to program it. And what I discovered, and I might fix it in the future, I don't know. What I discovered was that the speed input was not being read by the MCU. And I traced the circuit, I traced the input circuit all the way from the pin at the connector to the MCU, and I'm pretty sure that the VSS runs directly into the MCU. I can actually verify that right now. We can pull up the schematic here real quick, and I can verify that that is the case, whether that is the case. Not on page 1. Speed pulses. B12 comes into one of these breakout boards. There's 2 breakout boards on the ECU. Yeah, these 2 guys here, right? There's technically 3. A third one goes here. This is the P72 PM6 or PM3 knock sensor calculator board, or I guess knock sensor amplifier board is what it would be, and it would send data out to the MCU to retard the timing if you start knocking. So we have, let me change to this guy real quick. We have this guy, and the speed pulses you can see come in right here. I can't highlight because I don't have Adobe on this thing, but they come in here. They come through this system into the transistor there, the base. Yeah, okay. They then come into this Schmidt trigger, which just turns them from, so the speed sensor is a Hall effect sensor. There's a rotating magnet and a pickup, and every time it goes by, it sends a voltage spike down the wire. You don't want to send those spikes from an inductor straight into a digital calculator, because light's bad. It's no bueno por caca. But also because there's a bunch of noise in there. So what you need to do is you need to clean that noise up. So those pulses come in, they get rectified effectively. Actually, I might be able to find that guy. This is, what is this? RM, it's going to be what? RM something? What is this called? What is this called? What is this called? Doesn't tell me. It does not tell me what this is called. I don't remember if it's the front one or the back one. Oh, HIC, that's right. HIC something. I think there's just 1 and 2. Yeah, HIC 1 and 2. So this one is, let's find it. Let's find it on here. Am I blind? Miscellaneous inputs. I swear it's on here, so I've seen it in here before. It's not really all that important. I could trace it on the ECU to figure out which one it goes to. I was going to show you guys the actual components that are being called out in this quite poorly drawn schematic, if I'm being honest. But for now, it's fine. It's fine. So the speed pulses come in. They go through this rectifier. They come into this. So you have a pull-up resistor to 5 volts, and then a current limiting resistor into the base of this transistor. This transistor has a 5 volt. That's a PNP. That's a PNP transistor. So it has. Oh yeah, so the speed sensor pulls this down to give you. So it's normally high, and then every time it pulses, it pulls it down and makes this a negative. If sort of, it shuts the 5 volts off is what it does. So it makes it a 0, which is why you have this 10K pull down right here. Then you have another current limiting resistor here. 220K, that's really high. That comes into the Schmitt trigger. The Schmitt trigger will give you nice, clean, square pulses out from whatever he's powered by, probably 5 volts. We could find out real quick. Probably. So that's. I can figure out which one it is. This is one of those things that it would take a little bit longer. I might do later in the stream if anybody cares to know. Anybody pops in and wants to find out. Suffice it to say, it comes out to an IC, and that IC is the Schmitt trigger here. There's 3 or 4 others on the same IC, and they will run through their own respective channels. And then this goes into U1, which is IC1 here. They don't call them U on the boards. They call them IC and then their designator. But yeah, it goes straight into the calculator unit, right? So I trace that signal on the breakout board from the pin through the breakout board to the output of the breakout board, through the Schmitt trigger, from the Schmitt trigger into the MCU here. And it is reaching the MCU as a nice, clean square wave. Neptune does not report any speed. Everything else works. The map sensor and the throttle position sensor and the temperature sensors, everything else the MCU is reading, just not that. That means that either that channel is burnt out or something. It means the MCU is damaged. That's the only thing that it can mean, is the MCU is damaged. Which is less than ideal because you cannot now use that channel for really much of anything. Real quick, before I forget, I am actually going to pull up the live stream in here. That I can just have it as a monitor. I did not realize that was a thing. Wow. I have never seen the live stream, what the heck do you call this? In the studio. That's cool. Learned a new thing today. And YouTube is telling me that the live stream's bitrate is low. That's probably because I'm on Wi-Fi in the garage. And the modem, the router that I'm using, is technically on the other side of the house. That's probably why. I can check the settings real quick just to be safe. Oh. I did not know that that was set. It was actually set wrong. Never even checked it out. I don't know if changing it in OBS in the middle of a stream is actually going to affect anything. It might not do it until I, until I stop the stream and start a new one. Interesting. Okay. Sweet. Anyway, getting back to this. So this guy is, this is a semi-sacrificial ECU because a part of it is damaged, not working. %sure. This guy is a backup ECU. We can actually start the engine, as it were, with the simulator real quick, and I can show you that he does, in fact, work. The engine runs by doing this. I'm getting a phone call. Yes, sir. What was I gonna ask you about? The thing that I'm actually talking about in the stream right now. I know that, the ECU. Yeah. Okay, sorry about that. I'm back in the back. I'm back. I was showing you guys the simulator. Give me just a second. I'm gonna turn this guy on. Oh, I like that. That is great. Okay, so dealing with the schematic on the floor. I like it. I'm leaving it. All right, so we've got our engine simulator running right here. Don't even need to do. All it is 2 wires. Plug it into the wall, so we can see. Oh, that Luma key is funny. So we can see the orange lights are the injectors. The blue light is engine RPM. That's the sensor in the distributor that spins and detects once per rotation. Is bump, 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 like that. So they are running. The engine is running. I will set it back down. Can I set this so we can see it easily? Kind of like that. Alright, so I can come in here. I can turn up the engine speed, and we can see the injectors will speed up. Like that. We can turn down the engine speed, and watch the injectors turn down, and the RPM comes back to pulsing. The refresh rate of the Logitech is not all that great. I only have 30 FPS on both cameras, so it's it's fine. We can also come in here to the map. If we turn the map up, you can see, well, you can't really see, but the injector pulses get stronger, they get brighter. That's because there's more of a load. The higher the map is, that's your load detection. There's more of a load, so it has to put more fuel in, so they stay on a little bit longer. If we take the map and we turn him up, right, the injector pulses go very bright. We then take the TPS and turn him up, and now we are technically full throttle at about, I think this is just above idle. There's no, it's not telling me the speed, it's just the blinking of the lights. So what we can do is we can full load, and we're going to stall it out. Bam. Shuts off. Okay, we can then take and release the throttle there, and we would actually be there. Crank, 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 run! Bam, like that. Now we have vacuum. Look at that. Engine's running at idle. Ish. We can turn. So the factory ECU map has a rev limiter which cuts the fuel. We can see that here. So the injectors are firing. If we turn the RPM up beyond a certain value, bam! Oh, it shuts it off. Okay, no more injectors. Turn it back down. Bam! Engine's running again. It's a very small range on the pot because the circuit is not. It was just kind of thrown together. They threw this whole thing together kind of quickly. I imagine the upper range in RPM is probably like 20K. Turning the pot all the way up. And then the bottom range is 0, obviously. But the engine will shut off below 500 RPM, 450 RPM, something like that. So you can see that this ECU will run a car. If I plugged it in right now, it probably would run. I've modified the wire harness a teensy little bit. I'm not 100% on that. We might check that out at some point. I don't know. But I'm loving this Luma key. So you see in the circuit, right there, right? That's great. Alright, so bam, turn him back off. Get us back to the circuit. What I want to talk about the mod, or mods, I guess there's two, that I am going to do to this ECU. I'm actually gonna also bring you guys up here so we can see the whiteboard a little bit, because I'm gonna draw on the whiteboard. So, the first thing I want to do to the ECU is we're looking at this circuit right here. Okay, I've ordered the parts to emulate this circuit. So, in a less complicated format, let's draw this circuit up here. So, what we're doing Alright, so we've got the MCU here, we've got a 5-volt signal here, there's a 1500 ohm resistor here, 6800 ohm resistor here, and then we have, from this point, a thermistor, which is a 3K thermistor, apparently. Oh, that is not great. I would love to be able to look at that whiteboard a little bit better. What I need, I think, is a light there, facing down that way. I don't have one of those. So, we're just gonna have to deal with it. So, what we have is this is a voltage divider. And we can actually simulate what's going to happen with that voltage divider on fallstat.com. Great website. All kinds of handy usefulness. I don't actually have a circuit simulator installed on any of my computers right now. I have one from way back in the day, like an old one, that would probably do the job just fine. It was one that I got from the school, and it was just it's one of those licenses that it's not an expiring license. It's a student license that you get it, and it's yours because you paid for the class, which also included the cost of the program, blah blah blah, etc., etc. So there's a lot of freaking traffic on this road today. We're not even on a main street. We're like 2 streets off. Anyway, so we've got this guy right here, which is a current limiting resistor into the MCU. Then we've got that voltage divider, which sends a signal through to the MCU. Well, it doesn't go to the MCU directly. It goes to a multiplexer, which converts it from an analog to a digital signal, and then sends digital data multiplexed out to the main calculator unit. For the sake of this argument, it goes to the MCU. We're ignoring all the rest of it. So we can come over here. We can open up a new tab. Go to fallstat.com. There's also a bunch of other stuff on fallstat.com that is just wonderful resource. Go check it out. It's very informative. We'll start a new circuit, and this is going to be just a very, very simple circuit that we have drawn up here. I'm not even going to include the current limiting resistor because, for the sake of our argument, it doesn't really matter. So we're going to have a voltage source, there. We're going to have 2 resistors, 1 there, and my thumb is vibrating. We're not going to have 2 resistors because we want a thermistor, which is going to be in passive components. Thermistor, there he is. Thermistor. Okay, so thermistor, and then a ground. This is, wow, did not know you could do that. What? That's cool. I have never seen that before on this thing. Okay, so we are then going to want a scope right there. We want to see that voltage level. We then want to change this to 3K. And we don't want it to go that far. Realistically, we're only ever going to see, what, negative 10C? And maximum engine temperature, or maximum intake temperature of 100C is 212 Fahrenheit, right? So not even that. Maximum of, if we see 55C, we're in trouble. So, you know, it's interesting. That's not right. It shouldn't be giving us 0 ohms there. It should go... Did I not put K? R at 50C. I have a book for that. Where'd I put the book? Book! Alright, so the Honda factory service manual actually tells you, gives you a chart in here for the intake temperature sensor, which is 68. Alright, so at 50C, oh, did they give me a PTC? I think they gave me a PTC. Okay, so R at 25C is about 3K. R at 50C is about 750 ohms. There we go. Which means at 100C, we should be at about, okay, so let's change this. Make this 100, just a test. At 100C, we should be at about 150 ohms. That's not right. Maybe this is, the chart is very small. So 25C, at 40C we're at 1K. I need a little pokerator. So at 30C, oh, maybe that's a 4K. Let's that say? 100C 54. No. That's closer. 2.5K. It's hard to read the chart, really, and you're not going to find any more data anywhere without pulling the sensor and checking it manually and plotting the chart yourself, which I'm not going to do right now. Wow. Yeah. OBS and Fallstat do not play along well. They don't play nicely to each other. So we're going to turn Fallstat off for a second. But you saw the voltage there. As you moved it, the voltage would go up, and then down, and then up, and then down. And that's what we want, right? We want this voltage to move at some rate, and we want it to be identical. We want the new one and we're going to shut this off because I don't want that injector driver overheating and burning up. Even though I'm pretty sure I can get a new one. So what we want to do is I want to add a secondary intake temperature sensor that will tell me what the temperature of the air is in the air box prior to the air filter. Now the air filter is going to slow down air a little bit. The intake tube and couplers are going to slow down air a little bit. The intake manifold, the plenum, and the runners are going to slow the air down a little bit from the rate at which it can possibly move through into the air box from the outside air. Slowing it down is going to allow heat to soak into the air. Now, air is a very good insulator thermally. We know that air is a very good thermal insulator. One evidence of this is the ski resort in the middle of Dubai. You know, the desert with a ski resort in a building insulated primarily by air. They've got two domes. The inside they keep cool so they can have snow that's like actual water snow that they spray on the hill, while the outside is 100 and Dubai degrees. So I want to know what the temperature differential is between the incoming ambient air in the air box, which I will get not exactly but close enough with where I've placed the sensor in the tract, and where the air is running into the engine at the intake manifold. We're going to point him down a little bit. Most of the reason I want to do this is I just want to try to determine how much heat is creeping into the system so that I can make changes to the intake and plot them on a graph, on a chart, and determine what the best course of action is for reducing or increasing the thermal energy entering the cylinders. Okay, I should probably at some point install temperature sensors in all the intake runners, or install bungs on the intake runners and then move a sensor around with, you know, blanks and sensors. The problem with that is introducing anything into the airstream at that point is going to, because of how small the runners are, is going to fairly greatly impact the airflow into the cylinder, most likely negatively impact the airflow into the cylinder, which will kind of not negate, but it will definitely skew the results of any reading that you're going to get. Oh, actually, That don't look too bad like that. Okay. So to that end, adding the new sensor, I need to modify the ECU. The circuit in question, we can go back to him. The circuit in question is this guy that I decided, I called a buddy of mine and we talked about it for a minute, and the decision was made that I'm going to remove the wideband sensor from B14, or as every other piece of documentation aside from this calls it, B6. Well, the aftermarket community calls it B6. This schematic and Honda both call it B14. So I've removed these resistors from this spare ECU, and I installed a 2.2 and a 10K resistor in the hopes that the ratio alone would be enough. The problem is it's not the ratio, it's a current driven signal. So I do need the current because of that. You know, no, because the A to D inside the multiplexer is going to be, should be voltage driven. But the voltage is going to be directly related to the current. So it needs to be the same values. So the skew rate would be the same with the resistors that I've installed in my test bed, but the rate of change would be the same if the sensor also changed. I did it as an experiment. I didn't have high hopes that parts I had on hand would work. But I tried it and it didn't work, and it's fine. I was never able to get the signal generator up and running to supply a DC voltage because it introduces a ground loop into the ECU and simulator circuits, which ends up shutting the ECU down. It just turns off. It's probably a protection mode. There's protection circuitry on the ECU to prevent damage in the case the alternator or the battery fails in very particular types of ways. So it's probably that protection circuitry. I'm not going to bypass it for an experiment. I don't want to fry my spare ECU and have to spend, weeks in repairs, months trying to find parts. That would be the hardest part, is trying to find parts. People want stupid amounts of money for these ECUs today. They want, it's an $80 part at this point, as old as it is. People want $600 for some of these things. I'm like, it's insane. These people are crazy. So, I've ordered the parts. Funnily enough, I ordered the parts, and so I ordered them from Mouser. I used to use primarily DigiKey, but DigiKey's done some things with their website that There's a freight truck on our street. Why is there a freight truck on our street? Oh, the neighbors must have ordered something. Give me just a moment, folks. I'll be right back. I'm going to go see if they need a hand with whatever this is. I'll be back in just a second. the neighbors ordered a big thing that they needed delivered. I am back, by the way. The neighbors ordered a big thing. Why? Why can I not hear? This is Sparta. Let me check a thing real quick. Check a thing, check a thing, check a thing. Yoo-hoo. I can't hear my stream. Okay. I guess we're debugging this real quick. Because I would like to hear my stream. I don't know why I can't hear my stream. There we go. For whatever reason, so I use a program called FX Sound for my laptops. Because both of my laptops, they have abysmal speaker outputs, and FX Sound just takes and adds gain to the output. For whatever reason, the amplifier, the hardware on the motherboards, has the power to output to the speakers such that you can actually hear sound out of the speakers, but both Asus and Lenovo, for whatever reason, their hardware doesn't talk, like Windows doesn't talk to the hardware correctly. So with Windows, I don't know about Linux or anything else, but with Windows, you don't get proper audio output. I don't know why. So anyway, I've got my me in the background. We can get back to talking about the mod. So actually, I wonder if instead of this right now, we take this guy. Let me do this. Do this. Do this. We're going to copy this guy. We're going to paste a reference in here and move him down there. Make him just a smooch bigger. Where's the Logitech? Okay. So we don't, for this right now, we don't need the Logitech. We can do webcam. So they got their thing unloaded, the truck is leaving, audio will be better. Slightly better. Okay. Back to ECU. So I don't remember exactly what it was I was going to say. I was going to talk about, I'm going to mod the ECU so I can add the intake temperature sensor. In doing that, I'm moving the B6 line that is currently the input for the wideband on B6 in Neptune, my tuning program. I'm going to move him to the EGR lift input, and I'm going to run him through a. I need to run him through a current limiting resistor. So that's all on the same page, which is cool. I don't have to go that far to figure out what the heck I'm doing. So there is That's a 10K there. I don't know where F goes. I should find out where F goes. So the problem with the EGR position is that it's tied to battery voltage, not 12 volt regulated, not 5 volts, but direct battery, which is kind of weird, I think. It's probably to avoid a ground loop, so I don't have to send another ground to the EGR lift sensor on the EGR valve, which would just increase wiring and connector costs and all this other stuff. So what I'm going to end up doing is I'm going to cut the trace. So let me grab my spare CU here. So this comes in RM2. RM2 is this 12, this guy right here. So RM2 is this guy right here, this resistor pack. And they're wired complicated internally. It's not just a resistor and then a resistor and then a resistor. They're wired internally a specific way. So what I need to do is I'll need to come over to pin 4. Luckily, this guy is marked. I don't know if you'll be able to see it. This guy is marked. That should be pin 1. There's a dot on the part, and the silk screen has an outline. That's pin 1. So I need to cut pins 4 and 5 traces, which hopefully, so 5 is on top, comes over to this dot here, and 4 goes straight to the pin. So what I'm going to do is I'm going to wait a minute. Oh no, the throttle position does come. What I could do is I could remove RM2 completely, make my own resistor pack. I'm gonna have to think about this actually, because what I might be able to do is remove RM2, put a 3K ohm resistor between pins 2 and 3, easy peasy. Solder a 300K resistor from pin 2 to 1. But then I have no idea what the resistor from, well, I guess if I'm pulling the part out, I can measure the resistance from pins 1 to 6. That'd be more, that's going to be far more complicated than I really want it to be. So we're going to leave RM2 installed. If it didn't run the throttle position sensor and it just ran another system that I didn't need, I just pull RM2 out and just worry about the EGR position. But because it's attached to the throttle position, I'm not going to do that. So what I'm going to do is I'm going to cut the traces. I'll take probably a razor blade, maybe a razor blade. I might have, I have a friend or a buddy, or I know a guy that might be able to help me out and cut the traces for me without doing a whole lot of damage to other things. But I just need to cut the traces and then run a green wire needs to go like through the board though, that's the problem. I'm gonna have to sit down and investigate this, but I'm gonna run the wideband sensor into the ECU through the EGR position line and send that to... I'm going to try to do it, honestly. I'm just going to try to solder a jumper wire from 4 to 5. Just bypass that 100k ohm resistor right there. No, I'm not. No, I'm not. Every time I look at this thing, it's there's something else the way it's attached internally that makes me think I should not do things. I can redraw it. You know what? It's a stream. I'm gonna cut stuff apart anyway for the video recording. So let's take a look at RM2. Remove this. Let's redraw RM2. Because sometimes changing your perspective is all that you need to view your solution. Alright. So now we have, this is a battery line. Battery plus voltage. Okay, now it comes down, and it doesn't tell me what these values of resistors are. That's the biggest issue. Okay. We're going to come down straight off of RM2 there, or off that first resistor there, come into that resistor. Okay, now that ends that circuit. We then have, off of the middle here, we have another resistor that goes to ground. Okay. I'm going to put this down because I don't need to be holding this. The leads are pokey. They're pokey in my fingers. Okay, so from battery, go down through that one. Go down to that one. That comes down here. There's schmutz on my finger. That goes down to there. That goes straight to the MCU. MCU. Alright. Now, out of here, off of this ground connection, there's another resistor. Comes up there. And we have EPS. Down through there. It sits on the TPS side. Like that. Okay. The bottom of this guy, so goes battery, resistor that. There's a tie off that goes to ground. There's this guy. He goes up to EGR. Out of there, there's another resistor. battery. Second resistor. Oh, to the MCU. What am I doing? Battery, first resistor on the far right. Second resistor, next left from that. The output of that goes to the EGR valve. Okay? Through that resistor, we go to the MCU. Right? We then have this resistor that comes over right underneath that 5565. That's this resistor. He goes to ground. From that ground point also, we have, this is a 300K. The EGR is a 100K. The one that comes from the TPS, which is this guy, is 3K. That is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, we have 6 resistors, which makes sense. It's a 7-pin. The way they've drawn, I don't know if this is done on the PCB, these connections, or if that's internal to RM2. So you should be able to, what I might do, so I ordered some solder wick along with the resistors. It should be here probably Tuesday, honestly. Tuesday, not today. Tuesday, next Tuesday. So what I might do is take the damaged one, this guy here, and remove RM2 and measure these resistors. I might have to do that. Before I do the wideband mod. What I do need to figure out, I wish I had just like a benchtop laboratory power supply. Because I could apply a voltage to this pin. And I could find out if it will do what I want it to do. But for today, I don't have that ability. But suffice it to say that RM2 needs to be the circuit that is contained in RM2 needs to be slightly modified to finish the wideband input that I want to put on the thing. Neptune does have the ability to adjust, I think, timing and or fuel based on those inputs. Pretty sure. So I might end up doing that later and running that on top of the tune that I've already got. That would be potentially very helpful in fine-tuning some of the quirks of running this kind of older ECU and I forgot where I was going with that sentence too. Man, I'm going crazy. Either way, this input appears to be what I could do, looking at this, Wait a minute. I don't have to make a bunch of cuts and jumpers and go around the board and all that nonsense. I really only need to make one cut on one trace. Which is the input to pin 4. Take the input to pin 4, cut the trace, put a 10K resistor in the middle of a very small wire. I'll probably end up using a solid core wire, honestly, so it's stiff and it doesn't jiggle around a whole lot. And then I'll have to glue it to the board. I got a hot glue. I had a hot glue gun around here somewhere. I think it's in the 3D printer box. It's probably the 3D printer box, because that's where I would be using hot glue. So we just cut that line. Wow. We're gonna have to cut both. We are gonna have to cut both. Luckily, they're not that hard. So we're gonna have to cut that line and cut that line. And install a jumper. Kind of like that. And that will work. That's not hard. So what we'll end up doing is we get RM2. What camera am I on? Okay, so we'll take RM2, this guy here. So pin 1, get my little indicator here. So pin 1, 2, 3, 4. See this trace snakes up here to this pin. So we'll take and we'll cut the trace about right here and cut it back a little bit. I'll then take and actually, yeah, no, we gotta cut both sides. We gotta cut both sides. So we're gonna take pin 4, cut him back somewhere. Maybe right here would be better, kind of in this open area. Cut him back, cut the trace out a little bit so we don't bridge it with solder. Pull the solder mask back, solder a little jumper wire to there, solder a 10K ohm resistor to it, and then pin 5, 1, 2, 3, 4, 5, right here. He is on this side. There's a trace. So 1, 2, 3, 4, 5. There's a little trace that comes right over here. Comes this way and goes to... What? That does not go to pin 5? B, go away. There's nothing here for you. Go outside, thank you. Pin 5 says it goes to C42 DM7. Where is C42? C42, which is not even installed. What? Oh, because there's no EGR input. There's no need to install CF42 if there's no EGR input. So, actually, that'll even be easier. So yeah, so we can cut that trace. 1, 2, 3, 4, 5. It's really weird that this says it also contacts RM1. So where's RM1? And why is it claiming that it contacts RM1? RM1 is this guy. So it looks like it runs into pin 5 of RM1. What is pin 5 of RM1? Pin 5 is I'm gonna have to measure that, because this is slightly unbelievable. I don't believe what this trace is trying to tell me. So, let us measure it. We'll put it on the dingly dingly dings. Got dingly dingly dings. Okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Oh. Okay. EM5. Okay. Oh. Oh, the solder mask hides it. Okay. Okay. So 1, 2, 3, 4, 5. There he is. Okay. It ran under a piece of the solder mask, or the silk screen, I mean, and kind of disappeared, and it looked like it came out, but that was another trace. So that goes to there. Runs to there. DM7. Goes to there. DM5. Yep. Runs DM5. Okay. So, yeah, we can cut that trace. It's gonna be a bit of a pain, isn't it? So these DMs appear to be transient suppression diodes with 2 diodes per package. Mr. B, go away. Thank you. Outside. Outside is your life. Inside is my life. Thank you. Okay. Silk screen. Yes. Okay, so rambling aside, I need to cut the 2 traces, put a 10K ohm resistor in line. We are probably going to do that underneath, easy peasy. We can do it right there. So we can cut we can cut the trace for pin 5 and then attach, we can attach the jumper wire to the pin of DM5 that it used to go to. So we remove the resistors and RM2 from the circuit. So we can cut it there, and then we can solder it there, run the wire right through this open spot right here. And around to that spot there. Easy peasy. I wonder if I have a 10K SMD. Let's find out. Well, I've got these. What are these, 0402s? I've got these little SMD resistors here. They are not organized in this bin at all. But if I have a 10K, this guy. Yeah, so I'll go through here. I found 100 ohm. Yeah, let me go through these. Let me find a 10K. Because I don't think it goes into the MCU. There's no way it's a high current requirement. Tell you what, we can see if there's a rated current output on the analog pin in the UEGO book. So let's check that out real quick. Might be on the last page, the specification. There's a specifications page. Analog output, 500 hertz. It doesn't tell me analog output. I wonder if I can call them. I'm going to call them. So I've got me a 30300 UEGO, and I have a question about the analog output that the paperwork doesn't seem to address. I wonder if you guys would have a spec for the rated current output of the analog signal. I can't imagine it's probably gonna be like 5 or 10 milliamps.
Yeah, exactly. Anything good in our instructions at the end.
just
Alright,
for
don't
the
have anything published for it.
for the analog, it just gives resolution and update rate is all it is.
Update rate, yeah. Yeah, not a spec.
Wait.
We have a what is it that we're trying to do?
So I've got older Honda OBD1 ECU. I'm going to be cutting the EGR input line and running the analog out directly to the main calculator unit. Every single line that is analog that runs to the MCU has a current limiting resistor, but I don't know what the output of the gauge is, so I don't know what I need to put in for that line. I do see though, so analog output 10-bit. That tells me that it's, so is that a digital to analog converter that's giving us the analog output?
These are all questions beyond me.
Is there an engineer handy that might have helped design the thing?
Not handy, at least.
Usually when I call and I have questions, it's generally beyond the whoever answers the phone. I'm like, hey, I have this question about this. They're like, the guy that designed it doesn't work here anymore.
Yeah, that's what we're getting pretty close to.
So it's
I mean, if you want, if you could maybe that all down through an email, I can see if we can forward it over to our engineering team, see if we can get you,
okay.
maybe an answer you're looking for.
Is that the just the gentech@aemelectronics.com?
It is.
Okay, I will do that then, and hopefully we can find someone that has more answers than just what the documentation can provide. Alrighty, thank you, sir.
Keep an eye out for it. Alright, take care.
Okay, email time. Because I do need to know, because if I put too low of a resistor, the obvious problem potentially is frying the MCU, either that line or the whole thing. The MCU draws too much current from the AEM gauge and fries that thing, and I'd rather not do that. If I put too high a resistor, the only problem I run into is I have to unsolder the resistor and do it all over again, because there's just not enough current getting through to the MCU for the A to D converter. So yeah, I guess I need to send them an email real quick. So I'm going to send them an email real quick, and I will slowly read it out to you guys as I write it. So let's go. Okay. Suppose I need that email address. gentech@aem. Gentech. Electronics.com. Okay. Subject matter is Uego 30-0300 analog output. I have a question about the analog output capability of the Wago gauge. Current project is modifying an OBD1 onto ECU by sending the UEGO analog signal into the EGR pin, bypassing the internal voltage divider, and passing the analog signal to the MCU directly. I cannot find much information about the inputs of the IC OEM calculator. And thus do not know for certain the maximum current handling of the IC's A to D converter. I suspect that I will need a current limiting resistor between the UEGO and the MCU IC. I was wondering if I could... Wondering if you could provide some information about the UEGO analog output circuit. Number one, what is the maximum current output capability of the driver circuit? Number two, what type of circuit is being used, i.e., well, the documentation says 10-bit resolution. Does this mean that the analog out is a digital signal converted to analog voltage via digital to analog converter? I guess question mark. I know I said that like there was more to it, but I couldn't think of a follow-up. Does this mean the analog out is a digital signal converted to analog voltage via DA converter? If so, is the D to A separate IC, or is it a function of the primary controller on board, the UEGO? Now, I don't know that they're going to answer the second one because that's getting into like the realm of proprietary stuff, but I own the thing. I could take it apart myself, so I don't know how much proprietarianisms they're going to try to protect just via email. So I don't have this up on screen because I'm using my personal business email, and there's sensitive stuff in there, so I'm not going to put it up on the stream, obviously. But I read you guys out the email. I like doing thank you in advance for your assistance, if you can spell it right, and then just sign my name, Ryan, and send. Hopefully they'll get that and they'll give me a response. I mean, hopefully in the next 20, 30, an hour. Hopefully today. That'd be very nice. That'd be really cool. I'm actually gonna pull this off as a separate. We're gonna come over here to blank page, OBS. What happens if I turn this guy on? He gives me the blank page. That is not the one I want. So this guy needs to be that one. Bam! Okay. So now if we change and change back, and we change back, and we change. Okay. Hi, me. How you doing? So, Big Cannon, which gives me the webcam that I can talk to you guys, and this guy that we can look at the whiteboard. All right. So now we're asking that question. I'm going to empty out this bin. It's funny because I have multiples of these. I have 2 of these. Okay, 2 is not too bad. So we're gonna empty out these bins. I'm gonna move some of this stuff on the desk real quick. And we're going to empty out these bins on the desk, and I'm gonna look for 1K, I guess 4.7K, 10K, maybe 8K. We'll look for a couple of different values that seem reasonable for a current limiting resistor for a circuit of this type. It's 0 to 5 volts, so we can do the math and make sure that these resistors can handle the current. So, not that, not that. 150, there's a 4.7, there's a 10K. Not that. 470. 7.5. Do 7.5. 2200. 39K. Another 39K. 5K. 6.8. Do 6.8 instead of 7.5. 15, 3.3, 150K, 3M3, whatever the heck that's supposed to mean. 682.2. I guess we'll do a 2.2 just to be safe. 0.233, no idea what that's supposed to be. I'm looking for a 1K and like a 15K. So 47, 10K again. I think this is 2 sets of the same pack of resistors. Just 2 different people that made them, because I think I ordered them, looks like 1K3. I think I ordered them and I wasn't sure about the companies that I was ordering them from at the time. So I ordered multiples because they were like $3. So I think it's just 2 packs of the same parts. Honestly, probably it might even be the same people. I don't know. These handwritten ones are really hard to read sometimes, but then you got this one, 33R, really easy to read. Starts putting them in this guy. I just need a 1K, guy. Here's a 1K. Like this. You guys tell me. What does that say? Seriously. What does that say? It says... No idea. Not a clue. There's the mail lady. I'm not seeing 1K anywhere, man. I need 1K. $1K. Pretty sure it's a 1K. Looks like a 1K, right? Come on. There you go. That looks like a 1K to me. Alright. I do need to set up the soundboard on this laptop. Oh. Feels like there's a bug in my eye. I need to set up the soundboard on the laptop so I can give you guys some funny sounds. You know, ha funny. Not that other kind. Okay, so we've got these, I believe 0402s, surface mount resistors, itty bitty guys. We can use them, and that's stranded wire. In here, there's some solid core wire. I can use that guy to, I just use green wire. I could use the magnet wire. 30 gauge? Let's look that up, I guess. Put you on there. And then current rating of 30 gauge. Chart. Bam. Chart. Bam. Okay, so 30 gauge. Max current is 0.142 amps. So what is that in a fraction? I mean, obviously it's 142 over 1,000. I don't know, can we do that real quick? That'll move 1, 2, 3, bam. Okay, so if we cut that in half, that's 121 over 500. 121. What is 121? It sounds really familiar. 11, right? 11 squared. double check myself. So that's... Oh. Question is that's not even. So what? Oh. The hell am I doing? I'm looking at this, I'm like, wait a minute. That doesn't look right. God damn it. I promise you, I'm not this stupid. Okay. So, I mean, there's really no way to reduce that further, is there? Can we get something close? So, we could do 70. We could do 72. 72 is resistors falling out of packs. So 72 divided by 8 is 9. 500 divided by 8 is 62 and a half. So what if we do that? So 9 over 63. What is 9 over 63? Very close to that. Okay, so So 1 over 7 is 0.142857. So it's a teeny bit less. So it's like 1 over 7.4. Yeah. 1 over 7.2. 1 over 7.05. There you go. One over 7.05. So close enough to 1/7. But what that lets me do is lets me look up the current handling of specific resistors. So if we go to Mauser, right? Oh, did I not click that? Okay, so if we go to Mauser, look up 402 resistors. We're not doing that. We're not doing that. We're not doing that. Okay. I guess Mauser's out. DigiKey? Chip resistor, surface mount. We need, where's the size? Oh, 402s. Pretty sure they're 402s. And then we need, let's go with resistance. Minimum 1K. Yeah. Move over there. 1,000 ohms. 10,000 ohms. Narrows it down to 30,000. 1/16 of a watt. Yep, so the resistor is probably going to be our limitation. That's half of that. So, wait, what 30 gauge wire can handle more current than these resistors? What is... Okay, 0625. 2 1/4 times. 30 gauge wire. No way. These traces are smaller than that. Huh. Interesting. It goes up as high as a 10th. I mean, the standard is 1/16. There's kids that play in this damn neighborhood, guy. You need to slow down. Oh, it has the numbers there. So, let's take a look at the 8th watt guys. Because I have no idea what these are. It's just stock pictures. 10 cents a piece. Yeah, I have a feeling these are probably 16th watt. Which is, I mean, at the end of the day, we're talking, what is that, 140 milliamp capable wire. $63 milliamp. Oh, watts. 63 milliwatts. Which is going to depend on the voltage and the resistance. So if we have 5, if it goes to 5 volts, swings to 5 volts, 5 divided by 10K is going to be 500 microamps. 5 divided by 1K is 5 milliamps. So I have a feeling I'm probably going to put a 1K resistor in, looking at the numbers. I guess I can look for, let's look for the MCU real quick. See if we can't find information on it. I don't really have a whole lot of faith that I'll be able to find current information, so MSM 66 207 251. Is a 251 significant? I don't think it is. All data sheets usually has stuff. Click on the thing. I mean, it is an Oki part. OKI semiconductor. That says preliminary. So this actually does look like the original data sheet for the part, which means it's probably been superseded by something else altogether. That is pin 57 or 51? Probably 57. So let's look at 57. What is the current handling? Pin 57. What is pin 57? Pin 57 is, holy crap, this is terrible. Is that A13? Where is A10 to A17? A to D converter. Okay. A8 to A15. Eight-bit. Okay, so I need absolute maximums then. A10 to A17 is an input to the A to D converter. That's fine, we know that. There we go, absolute maximums. Log input voltage. Log reference voltage. VR. What is the reference voltage? Probably 5 volts. I would imagine. Okay. Fan out. Curve on that. Input current. Two and 3. I need analog input current. That's addressing. Then we're into the clocks. Oh, A to D, there we go. Analog input voltage. Max VR, reference voltage. So I'd have to look at the reference voltage. That's fine. It's only going up to 5 volts. I know it's fine. I need maximum current. Probably going to be a high impedance input then, if it's not giving me max current ratings. Registers. I should probably save this data sheet at some point. Because who knows how long it's going to be available. Who knows when. Of course, I'm going to need it when it's no longer available. That's how this stuff works. Right? Sometime when I actually just need the whole thing. Tell you what I could do. I could probably update I could probably reuse this ECU at some point and update the hardware contained on it. And then I'd have to have somebody design me the software to run the engine correctly. So we have a game plan. We don't need this anymore. I'm gonna message my roommate. Oh, there it is. I also want to talk about new ECU requirements. This whole time this thing's been flipped backwards. Everything you guys see has been backwards. I apologize for that. I can read stuff, because I'm a dummy head. Sorry about that. Alright, so where we stand today, the ECU. Okay, so obviously I needed to run the engine, and so I don't know if I want to limit the ECU design to 4 cylinders, because I like 4 cylinders, or if I want to have the option for the new ECU, whatever ECU I choose, or that I have to design if I have to design one. I don't know if I want to limit it to 4 cylinders, or if I want to have the ability to run 6 or 8 cylinders. I'll probably never go above 8. So 8 would be like the upper limit if I were going to. So I guess what we can do is we'll do requirements in black, and we'll do unknowns in blue. So let's start with that. So unknowns. X. X less than or equal to 8 cylinders. Okay, that's an unknown. List of requirements that I have are, we're going to do the basics, right? So the basics are going to be ECT, IAT, colored finger, idle control, map or math, I don't know. Probably both. Since it's not that hard to design an ECU with both. Most aftermarket ECUs have the ability to use both a map sensor and a math sensor, so we'll leave both. Actually, I want 2 IATs times 2. We need water temp, intake temp, we need TPS. We're going to need injector outs and ignition outs, right? So let's just do... Hey, mail lady. Thank you. So injector out, ignition out. What else do I want as a minimum requirement? Control via ECU of fuel pump. And AC. Because what I would like to do is I would like to have the AC PWM controlled. So that you can reduce power consumption a little bit by having the HVAC system or PWM controlled. This same weird group of flies is back in the garage. Go away, flies. They're not like just regular house flies. They're I don't know, they kind of bunch in groups. They're weird. They're strange flies. Okay. The ECU should also control steering power. Which means I'm going to need steering angle. So this one, actually, let's move this one to optional, or I don't know. Because I might be able to do it with its own standalone, just a steering module. So, okay. I also need a PWM out for the boost clutch. So, and that one's going to need greater than 4D map. So I want to be able to use RPM, engine load, it says encoding overloaded again. So I want to be able to use RPM, engine load, coolant temp, intake temp, probably exhaust temp, which is going to lead me to another thing that I want in there also. So I want full control over when boost occurs. I don't want it to just be foot down, boost on, foot up, boost off. I don't want it binary. I want it to be able to control the boost level, which also means I'm going to need a boost controller. PWM, which is going to be a bypass or a blow off of some kind. We'll just put bypass. So we need a bypass control output. Pardon me while I try to scare some flies. Why insects seem to think this garage is where they need to be. Go outside. It's warm. There's food outside. Can't wait for winter. No more buggies. Okay, so boost controller bypass, boost clutch PWM, because what we're going to have, so we're going to also need a blow off valve and a bypass tube servo So we're going to put copy lines there. Because we don't want to be damaging the turbine on throttle snap closes, so I might be able to get away with a manual blow-off valve. I don't know yet. I have to start designing the system and figure out if that's going to work for me or not. I also want exhaust gas temperature gauges. The question is though, so what we're going to do, what I'm going to put on here is I'm going to put EGT and AFR. So we're going to put those on there. I don't know if I want all four to be instrumented or just to tune. Yes, I do. I do want all four to be instrumented because I can do, in the effort of making maximum economy, maximum efficiency, maximum energy and chemical efficiency. The idea is fuel economy, but maximum energy efficiency also translates to maximum power output per fuel amount used as well. So it's kind of a double-edged sword type of situation. So you do want each cylinder instrumented fully. I need to redesign the intake because the intake that is currently on there that Honda designed with these things, these engines weren't designed to be peak efficient. They were designed to be efficient enough. And the freaking flies are back. Damn it. Go away, flies. If they weren't in my face, I really wouldn't care. Okay, well, we're doing this the hard way, I guess. They want it the hard way, they're getting the hard way. Yes, thank you. Yeah, if they stay over there, I don't care. I really, really do not care. When they're buzzing right in my damn face. I hate bugs buzzing in my face. Anyway, we definitely want to instrument all four cylinders so that we can tune all four cylinders simultaneously. To that end, we also want, not all four, but we want NOx sensors. I'm going to have two. So I'm going to have a NOx sensor between 1 and 2 and 3 and 4. And we're going to use those. I'm going to have to do a lot of testing and experimentation, but we're going to do those to detect per cylinder NOx. Sort of. Hopefully. What I'll have to do is, like I said, I'll have to do a bunch of experimentation and measuring to determine if I can get that precise with the measurements. NOx sensors are not really precise elements, and it's all going to depend on the signal conditioning mostly. So I might need to have an external NOx sensor amplifier for these guys, and then I just run that data as yes, no digital data, knock, no knock, into the ECU. I would like the ECU to be able to handle that, where I can tell it this type of frequency in this band is a knock in one cylinder. This frequency in this band is a knock in multiple cylinders, which would give me sort of finer control over the whole thing. I don't know that that is necessary or is going to be possible altogether. That's a I'll find out when I get there type of thing, but I definitely want multiple knock sensors. That is a requirement. So I need what else am I gonna need? I guess I could open. I'm not gonna open Neptune, I guess, because it's not on this computer anymore. I don't think it's on this computer. It is not on this computer anymore. Okay, so let's see, things I need to do and things I want to do. Fuel pump. There's no TPMS, so there's no tire pressure. I don't want the computer controlling brake lights or headlights or any of that. That's what switches are for. These new OEM cars where they're controlling literally everything out of a computer. Terrible idea. If I turn my turn signal on, it should not take a second before it starts blinking the light. It should start blinking the light immediately. If I hit the brakes, I got a weird thing on my leg. No idea what it is. But computers should not be controlling most of cars. The only thing you need to control with the computer is the engine and the transmission. Windows should be switches, not computers. Lights should be switches, not computers. Control mechanisms, the way that you operate the vehicle. The steering should be mechanical, not electronic. The brakes should be mechanical, not electronic. Like now they've gotten to a point where your steering is a sensor with no mechanical connection to the wheels at all. There's cars that have no mechanical connection to the wheels at all, and then it's a motor that drives your steering. That is stupid. That is incredibly stupid. So incredibly stupid. I cannot believe how incredibly stupid that idea is. Oil pressure. Oil pressure and oil temperature. Those aren't going to be used for a whole lot. They'll be binary with thresholds, just for protecting the engine. If for whatever reason all your oil runs out and you have no oil pressure, the engine won't run. Simple as that. Water and air, fuel. Do I want fuel temperature? Because with fuel temperature, you can control lean burn. You can more safely have more control and run leaner depending on fuel temperature. With hot fuel, somebody can correct me if I'm wrong, but hot fuel will atomize better than cold fuel will. Hot fuel is slightly less dense than cold fuel is, which means coming through at the same pressure, through the same orifice, you'll get more fuel with cold fuel at the same opening time than you will hot fuel, because the viscosity does not change nearly as much as the density changes in the range that we care about that we use in automobiles, for the fuels that we use for automobiles. Gasoline and diesel primarily. Diesel does gel, so diesel's viscosity changes greatly over a specific range of below a specific range. But this is gasoline, I don't care about that. I don't plan on converting it to diesel. Oh, we're gonna need boost pressure. Oh, no, that's covered under this guy here. Map and math. Well, actually, if I do math, I will have to also have a map for boost pressure, because I need to know how much boost I'm putting in. But mass airflow reads the total amount of air going into the engine. I think I would prefer a map system over alpha N. Mass density, I think, makes more sense for boosted engines. I could look it up real quick. Let's look it up real quick. Okay. Oh, speed density, sorry. I actually do that every time. Every time I'm like, oh, mass density, right? So for a boosted engine, what's better? For NA, it genuinely doesn't matter. I want to say alpha N is more precise. Yeah, it is a requirement for any boosted application. Okay. Wait, what? Mass airflow. Okay, so I guess I need to look up map versus mass for tuning boosted. I thought alpha N was math. Did I remember this wrong? I thought mass airflow was alpha N. Maybe I'm remembering the wrong thing. Jesus. And it's not a frickin' Yes, I know what it is. The heck is that noise? I think it was a bug. That was a weird noise for a bug to make. It sounded like a cicada. Sort of. It sounded like a cicada stuck in a bicycle spoke. Map is difficult to tune? What? Relies on a well-tuned VE table. I don't even use VE tables. This ECU, well, I mean it's the hardware that limits me. But like, yeah, I don't use a VE table. It has it. The Neptune has a VE table, but I don't use it. Less forgiving to modifications? What? So apparently I've been doing it the hard way this whole time. I thought it was easy. Yeah, so the map you're going to want to use for boosted applications, which I'm going up to 8 PSI. Actually, here we go. Here's the thing I've been kind of wanting to make a video about. So that is the list that I can think of right now for the ECU requirements for the engine I want to build. Go away, fly! Out of my face. So let's go. I'll show you guys. So there's Zealworks. Zeal Auto Works. It's not. There's no problem with this page. Jeez. And this is why the constant update culture that we've evolved into is stupid, because it just breaks things that work. I don't care. Oh my jeez. So no, I can't show you guys something because somebody somewhere decided that their idea of security is more secure than my idea of security and trusting a web page that I've used thousands of times. It's retarded. No, you won't do that either. No, you're not going to work? Because I don't remember the freaking values. I need that page. That one works. Why won't that one work? This one. I want this one. Well, I guess I won't show you guys. Incredibly irritating. Transmission page work? Transmission page works. K-series page work. K-series page works. H&F series. H&F series works. Why does D-series page not work? No. This is oh so incredibly stupid. Did somebody save it? Somebody saved it. Huzzah. Which means I'm going to have to save it myself. Okay, so D15 block, D15 crank. The head is going to be the Y7. The pistons are going to be the B7 pistons, the engine that I have in there now. We're using B7 pistons with the, oh, wait. No, it's a D16Y7, that's right. The D16Y7 bits. Everything D16Y7 with D15B7 pistons. I am going to have to measure the wrist pin to piston top height. And I'm going to have to measure the piston top volume, the dome, dish, whatever, volume. And make sure that this thing will actually go together without slamming the valves into the piston. But the head gasket, we were going to use the Z6 head gasket, I believe. So if we leave, I don't know if the block or the head have been touched at all on the engine that I have. So we're going to leave it at 0. We're going to assume that it's fine and we're not going to touch it and they're flat. That might change in the future. So we can do the math with, you know, both one and then the other. So that's fine. Bam. That gives me 12 1/4 to 1 compression right off the bat. D16Y7, slap some B7 pistons in it, 12 1/4 to 1. Now the problem with this 12 1/4 to 1, what happens if I put in the D15 crank? It has a shorter stroke. Yeah, it takes me down to, if we're gonna turbo it, kind of levels. Which I don't want to do. I should measure the crank. I don't know if I've got the crank out yet or not. I should measure the crank just to verify these numbers. So the problem is running a 12 1/4 to 1 compression ratio, static compression ratio, and then, because that's going to be, does it tell me? I don't remember where I found it, but I found a place you could calculate the dynamic compression ratio, and depending on atmospheric pressure, I want to say we could see up to 16 or 17 to 1 compression, dynamic. And on these internals, that's really pushing it. The biggest issue I'm going to have, because I'm going to get H-beam rods, and I might have to notch the block to fit them, which is not an issue. But what will be an issue is the crank bearings and the holes in the block for the main bearing caps. That's what I'm going to have to worry about the most. It's going to be ARP head studs, MLS gaskets, upgraded valve springs, stuff like that. So it's, you know, the biggest issue is going to be the block and the crank bearings. Those are going to be my primary concerns. But I'm also only going up to, I think, 8 psi, which this calculator, for whatever reason, this is an older version. The new version has a boost section that you can put boost values into. Yeah. So this isn't a D series, obviously, but tell you what, we can rob the values from the D series and slap them into the B series. Bore and stroke 75 and 90. And actually, we're probably going to go to 76. Deck height for that guy is 212. Combustion chamber volume 3280. Pistons are going to be negative 150 and 3070. Oops. And I can always have the pistons modified. I can get taller pistons that I need and mill them down. That's not that big a deal. Rod length is 137. Head gasket gonna be 037, and we're just gonna leave the other the same. We're gonna leave that. So at 0 elevation with 8 psi, what? Why does that give me a completely different number? One millimeter on the bore should not change. Oh, really? It changes that much? Woo. Okay, sure. So what we can also do to mitigate some of this is we can have the combustion chamber milled out. So if we take off a teeny little bit in the combustion chamber, we can drop that back down. So it was 32.8, so if we do 33.25, that gives me 12.4 to 1 compression, and then we add 8 psi, and that takes us to 19.2 to 1. That is a lot of compression for a gasoline engine with aluminum parts. So we could do a little bit of looking, right? And we can say, max compression on a gasoline engine. Right? So we can look at fuel octanes. There's a chart. Compression ratio 12 to 1. Minimum octane 100. I'm planning on running pump gas. It's going to be premium, obviously. We're going to run 90, 91 or 93. Whatever maximum we can find. That's why we're going to have all of this instrumentation, is specifically so that I can run pump gas without too much of an issue. Because you can run 12 to 1 on pump gas if you tune it correctly. I mean, case in point, the Camrys are 12 to 1 engine. The new Camrys are 12 to 1 gasoline engines. And I know a guy that has one, and he runs it on cheap. He doesn't put premium in it. He runs it on 85 here in Utah. 85 octane. Might as well be kerosene, man. I should probably look up like Honda D series. What's the max compression ratio people have run on like the stock kind of engines? I mean, people have built these engines to the D series engines to 500 horses, I think, without doing major metal modification. So it should be fine. I'm gonna get H-beam rods. We're going with forged pistons probably for the B7. Because I do plan on running lean burn also. What's also going to have an effect on that is I'm going to have to do a little bit of investigation still into combustion chamber shapes. Back to what I was saying. I'm going to have to do a little bit of investigation into like combustion chamber shapes. Because if I can get the quench just right, between the piston and the combustion chamber, and I can quench all or most of the air directly into the center on top of the spark plug electrode, I can run with a leaner mixture without having to worry as much about detonation, long burn times, hot spots, burning holes in the piston, the cylinder wall, or the head. So that's something. The Honda engines initially were designed with really good quench anyway. I do need to look at the Honda VX, the Civic VX. I don't remember what engine was in that thing. I don't remember if it was a B7 or what it was. Yeah, and I keep getting encoding overload popping up in OBS here. So let's look up. Civic VX cylinder head. So the VX was the Z1 engine. Okay, so let's look up. Let's look and see what that was shaped like. That's that VTEC single cam. The VX was actually really efficient. So E15Z1 cylinder head. Want a picture of the combustion chamber. I want a clear picture of the combustion chamber, something like that. Okay. And then I want a D15 B7. Oh, crap. Damn it, DuckDuckGo. Okay. So we want this guy as a picture. Oh, yeah, thanks. I just want the damn picture. Open image. Thank you. Jesus. It doesn't have to be this hard, people. Where's that clean picture I found? This one. Open picture, new tab. That's fine. And then I want the D16 Y7 cylinder head. And we're going to compare the combustion chambers. Well, I don't need to look it up. I have one. Okay. So we're going to move the camera real quick because I need to walk around it. Stare at the whiteboard for a minute. I'll be right back. Can't be it. This has got to be a... Oh, this is the one. Wow. This is the Y7's head. Okay, P2F. Okay. So, we'll move you guys back over here. Real quickity quick like. We'll set the head up. Not like that. That's gonna fall over. Set the head up on the deskity desk here. Alright, so P2F, that's the guy I've got. That's not it at all. Alright, so that's the B7 head. We need the zoomity zoom in on, well, I don't know why I'm doing that. I have a B7 head also, sitting right beside where this one was. Duh. Duh. I don't know what this piston is. I'm 99% certain. P2E. That is the Y7 piston. I don't have a B7 piston laying around, but we can go find a picture of him. The B7 piston is a flat top with valve cutouts, I believe. So, let us tomato. Alright, so the M9, this is a B7. Okay, this is interesting. OBS. So I'm actually going to grab this guy. Come on. just a corner. Do not control me. Alright. So, we have two heads here. We have this guy, which I need to turn. Stand by, I need to turn the Luma key off. Alright. So we have this guy right here. It's the Y7 head, the P2F. And we have this guy, which is the B7 head, the PM9. What's interesting to me is those combustion chambers look damn near identical. I place you on here. Okay. Okay. So if we go back to our calculator, real quick. We go to the head. The B7 has a bigger combustion chamber because I believe it is deeper. Where's those verniers? Vernier. Okay. So I need also a flat edge. Donde está la flat edge? What do I have that I can use for a flat edge? Not 100% straight, but it should give us kind of a rough idea. Alright, so if I measure the depth of the B7 from where the plug sits to the surface that is the top of my straight edge, not the actual combustion chamber, but that guy is 19.2 millimeters deep. Okay, and if we do the same measurement here, oh yeah, that guy is 17.15 millimeters deep. Alright, so if you take you could mill a lot of material off the B7 head and get a lower combustion chamber volume. The problem is that brings the valves closer to the piston. So the Y7 piston is a dish. What is the B7? I'm pretty sure the B7 piston is a flat top with cutouts for the valves. So we're going to come back over here. E15 B7 piston. Bam. That's not it. Pretty sure it's this guy. Yeah, see, those are flat with just cutouts for the valves. So if we go back to our calculator, the dome is negative, means it's a dish, and that's a tiny amount of 1.5 cc of dish is tiny. If we go to the Y7, is 7.4 cc's, which is that whole dish shape. So yeah, all we're doing is if we build a D16 Y7 with flat top pistons, the funny thing is, so those angles on the valves have got to be different than the valves on the B7 head look to be a little bit further apart. Huh. Yeah, that makes sense. If you bring the valves down, because you're bringing that material down, so if you bring the valves, if they're like this, and you're bringing them down, they're gonna get closer together, right? So as you do that with the same angle, obviously. Duh. Okay. So that is what I'm thinking for that. Then what I'm gonna do, so and what I might do, so I'm gonna have to do some math at some point, right? Because I want this to be 12-to-1 compression. Like I just want it to be 12-to-1. That's just what I want it to be. So this head says USA on it. That does not bode well. We're gonna put you back up here. Like that. I'm gonna put these parts sort of away and stick them in there. Well, you stick the B7 head in there at least, and the piston. Well, the piston actually I'm going to stick over here. That's what I'm going to do. Stick it with all the rest of the metal parts out of the Y7. Stick the caliper toolbox. Okay. I wouldn't just ruin that scanner. It's been sitting in the sun for a while. Alright, so B7 head goes in the tote. I'm also gonna have to open up these ports a little bit. Problem is there's not that much meat to open up. But you open them up just the smoochity little smooches. Oh yeah. The valve cover for the Y7 is like the Toyota valve covers where it's tubes for the spark plug tube seals. That is good. That is one of the reasons I like the D16s. Is because of that. Right there. Those tubes. We're just setting you on the ground for now, I guess. Alright. What else needs talked about? Besides the fact that I'm just waiting on parts at this point. Waiting on parts and tools. Parts and tools. Ah. I wonder if I've gotten a response yet. I have not. Okay. Well, I was hoping they'd get back to me real quick. Can you just change this? Like, can I do that? No? It's an output only. Alright, so if I take the combustion chamber, right? Where we're at, we're doing that, we're doing that. Wait, what? This is not out of the hole. Oh. What? Yeah, so if we increase the combustion chamber just the littlest bit. It gets us down into safe territory. I don't know why claiming that the piston is out of the hole. I might need to do a B7 connecting rod, H-beam connecting rod. Or a custom length connecting rod. Guess I could do the math. We take 40 off of that. Yes. I might have to increase the combustion chamber size just a smooch, or I could mill the piston down, just straight down. Compression height of 29.5. We put the Y8, which is an MLS gasket, so probably end up getting the Y8 gasket. Sticking that in there. And if we remove a millimeter from the block deck, that's a lot. So half a millimeter? That'll put me right at it. Even the head alone, milling a millimeter, 1.2 millimeters. Oh, 1.2 millimeters. Where's that? Yeah, I got plenty of room up top. So yeah, put the engine together, make all the measurements, calculate the clearance. If the piston does come out of the deck, mill it to the deck height. Then I got the gasket height too. It can come out of the deck some small amount less than the total gasket thickness. So 5%, 10% the gasket thickness, the piston can come out of the head, or come out of the cylinder without colliding directly with the head. What I might end up needing to do is milling the head to match the bore, the combustion chamber to match the bore if the piston is coming up out of the deck. But, long story short, 12 to 1, Pro Charger with a clutch. Making the clutch is going to be fun. I'm going to use just the AC clutch. That's what we use for like hydraulic stuff all the time. Not a big deal. I don't know how much power it takes to turn the Pro Charger that I've been looking at. It's a little guy, and it says minimum engine horsepower like 120 or 150, something like that. So I don't know how much power it actually takes to get the thing moving, and I don't know how fast that clutch is going to wear over time. That's going to have to be an investigation on itself. But we can probably also, what we can do right now real quick is we can search for fuel injector calculator. Let's put it on this guy so you guys can tag along with me. Okay. Crank, target power, maximum 250, number of injectors 4. We're gonna say supercharged because technically that's what it's gonna be. The problem is I don't actually know the brake specific fuel consumption of this engine. So I guess we can start with 0.85 and then fiddle with it a little bit. No. What? Wow, we're gonna have to go big. So I have 240 cc per minute injectors in there right now. Oh no. What if we run up the duty cycle though? That's not going to change anything, is it? Okay, that's fine. Turbo going to change it? Turbo doesn't change anything. How do we calculate brake specific fuel consumption? Oh. Going horsepower. I think that's just giving you the number based off of values you've measured. I need to get like a rough idea of what it's... Yeah, you have to have some measurement. I know the Honda engines, so has somebody measured for the specific vehicle? Because we can go with that and then like minus 5% or so. Wait, what? the chart's gone. There was a chart. Okay, so fourth one in. What? Oh. Uh. I'm gonna make this bigger because squinting is annoying. I don't care about a caterpillar. There's got to be somebody that's measured this before. I just want something close. It doesn't have to be exact. No. Nothing. I guess we could look at the Wikipedia page. Yeah, it's power over fuel used. I get that. Really? That low? Okay. I guess I'm estimating the wrong end. I mean, I guess I could do a little bit of calculating because I have some numbers. So, cruising at 80 miles an hour. I'm probably using about 40 horses-ish. It's 14%. 14%. 135 cc's per minute times 60. Divided by, what is cc's to gallons? 3785. Just to make sure, volume, cc's. Oh, I need gallon. 1 gallon is 3785. So that divided by 3785 is 2.13 gallons. Gasoline is 6 pounds per gallon. So 6. No way. Oh yeah, 'cause 40 horses. So that's 6 times 0.13. That's 12.8. 12.8. 0.32. Okay. Yeah, I was estimating on the wrong end. At cruise, we'll just call it cruise, 0.32. It probably rises under power, so let's call it 0.5. But if we're doing boost, it goes up for boosted engines. Increases the fuel consumption. So means actually the Honda's really good in A. So let's just do just to be safe, let's call it a 0.65. Okay, so 0.65 at 250 horses. We're gonna need 414 cc, so 440s or 420s. If the engine runs like total crap, we could need to go up to 550s. If I can keep the fuel efficiency, or if I can keep the energy efficiency of the engine about the same as what it is, and we can do like 0.4. These fuel inject. If at 100 horses, I'm using 34% duty cycle at 240 cc's, and I double that, we need double the fuel. So that give me 60 something. I should be able to get close to 250 out of these injectors. I might have to put 300 cc injectors in it. Nice. Nice. Yeah, nice. That's a thing, right? Where do you mother? Okay. 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 So, yeah, stuff. Lots of stuff. Lots of stuff. Oh, how long have I been going? 3.5 hours. Nobody has come to watch. Nobody has come to see me. Oh, it's so sad. Extreme health. No idea what that is. Huh. Okay. I didn't even know this was a page in YouTube, honestly. Like, this is cool. Start a poll from in here. Oh, there it is. Oh. What? Oh, you cannot. You can't vote on your own poll. Unless you have a secondary account, and then you can go log into it and do it that way. Okay. Well. What else? I don't know. What else was I going to talk about? Encoding overloaded. Why is the encoding overloaded? Alright. Faster? Try that. Probably need a more powerful machine to do slower encodes. Are you going to... Are you okay? I mean, it's... What happens if I do that? Are you happier with that? I don't know why you're suddenly not happy. Okay. What if I do this? Okay. And then stop recording. Because I don't know if the... Okay, so... recording encodes separately. Okay. I might end up changing that to use stream encoder, so I don't end up running into that encoder overload, killing the stream. Because I'm probably encoding the video priority, and then once that's done, encoding the stream. Which I would prefer to have the stream priority. But that would kill the video encode. The video would look like crap because it couldn't encode properly. Still doing it. Why are you still doing that? You should not be overloaded. You're a frickin' 16-core Ryzen. Come on. Wait a minute. I'm not even using the video card, am I? Barely. Am I encoding on the video card? No. Why the hell aren't you encoding on the video card? Seriously. In OBS, use NVENC. NVIDIA says it can. I guess the question is, does my 1660 support? Because I did increase the bit rate earlier. Bring the bit rate back down? Okay. Okay, so I'm going to end the stream here for today. Not that anybody cares. I'm going to end the stream here for today while I do a little bit of debuggerating, trying to make the content and the quality better. While I do some research, try to figure out how to make this laptop handle the encode stream better, more regularly, without failing, without crapping out on us. So I will see you guys later.